Hello there, my name is Matteo Balla, and I just thought that you guys might think this is interesting. This is an Arduino-based robot that I made to draw images. Every image is a unique work of art because of the swinging pendulum movement. This allows for different waveforms inside of the image itself, or the grid pattern. So, if you can see that this is a very large image of my eye. On the Arduino that it's being powered by is something called a motor shield. And what the motor shield does is it allows the Arduino signals in the form of G-code to be sent to the stepper motors. And these stepper motors are actually holding on a beaded blind cord that you use for, blinds or shutters that you would have in your house, on a sprocket that I printed. And on this sprocket it has small indentations to hold the beaded blind cord so it doesn't slip. I've also calibrated the weight on both the sides of the beaded blind cord to hold up this pendulum or gondola to hold the pen. This pen is ever so slightly moving and swaying in different places to give a different kind of a staticky effect to the image itself. On the gondola, there's a small servo motor, and what that allows is that the pen can then lift off and not draw in certain places. Then when it is ready to draw, the servo motor will then actuate down, putting the pen onto the spot. And there's also a weight on this, allowing for these two weights to be perfectly balanced as that one, so it would stay in the same spot, allowing you to not have any upward movement or downward deceleration. On here I have some printed motor mounts, and what these mounts are just there for is to hold the motors out from the print bed itself. And then I have a small case to hold the Arduino in, just allowing for some added protection. On here we have a USB cord going to a laptop, and what on this laptop is sending G-code commands, basically telling it where to go. And in that way that it's telling it to go, is slowly dragging the pen in that spot. And then there's also commands that will tell the pen to lower or raise. And because this pen is being raised, it will not draw in a certain area. This G-code is being translated from the input image, which is just a normal image that we have chosen off a JPEG or a PNG file. This image then is sliced up into pixel lengths, that are then put into the small pixel grid on this image. So, what my robot relies on is the Pythagorean's theorem. This robot is a very small version of it, basically explaining the Pythagorean's theorem for other viewers. So what I would do is, in this robot, it is built on the LEGO Mindstorms platform. It's a very basic entry-level robot system. I've also printed sprockets very similar to the ones on my larger robot. On this, I've also used the beaded blind cord that I have on that as well, along with counterbalances and a gondola exactly like that. And what it's basically demonstrating is how my robot works by using the Pythagorean's theorem in a smaller package. So what I would do basically is I would choose a spot, maybe 813 over here. What this calculates, the Pythagorean's theorem, is that the A length and the B length added together, the A length squared and the B length squared are the same as the C length squared. So what I would do is I would take the coordinate of my A length, which I chose A. That would be my X coordinate. And then what I would do over here is I would choose 13, which was my Y coordinate, and I would let it fall right into that spot. And what we have here is we have two triangles. One here and one here. Funny that I was printing an eye and now we're talking about triangles. Illuminati confirmed. What I'm going to do here is I'm going to measure out this length, which is 8, and this length, which is 13. And I would do A squared, which is 8, A squared, which is 8, plus B squared, which is 13. I get 233. That is the area of the square in this spot, not the triangle. And if I take the square root of that, the square root is 15.25. That is the hypotenuse length here. and we were trying to determine the length of C. So, it's a moment of truth. Let's see if it was C. 15¼ Basically, this has just explained the hypotenuse length in relation to the x coordinate and the y coordinate.